In this video, we're going to talk about ratio test. Let the infinite series be series of non-zero terms. And let limit as n goes to infinity of absolute value of a of n plus 1 over a of n equals L. If L is less than 1, then we can conclude that the infinite series converges absolutely. If L is equal to 1, then the test is inconclusive, which means that we have to try different tests. Now, if L is greater than 1, then the series, the infinite series, diverges. So let's take a look at some of the ratio tests. You have an infinite series of n over 4 to the n power. So what is a of n? A of n is n over 4 to the power of n. And what is a of n plus 1? So instead of n, you got to plug in n plus 1. You end up getting n plus 1 over 4 to the power of n plus 1. So now let's apply the ratio test. So limit as n goes to infinity of absolute value of n plus 1 over 4 to the power of n plus 1 over n over 4 to the power of n. So if you simplify this, you get limit as n goes to infinity of absolute value of n plus 1 over 4 to the power of n plus 1 times 4 to the power of n over n. So you end up getting limit as n goes to infinity. This is the same thing as n plus 1 over n times 4 to the power of n over, what is 4 to the power of n plus 1? The same thing as 4 to the n times 4. So 4 to the n cancels out. You get 1. Now as n goes to infinity, you know that that goes to 1. So you end up getting 1 over 4. Now this is less than 1. So what can we conclude about this infinite series? This infinite series converges absolutely by ratio test. Now you have an infinite series going from n to 1 to infinity of 2 to the power of n over n. So what is a of n? A of n is 2 to the n over n, and a of n plus 1 is 2 to the power of n plus 1 over n plus 1. So using the ratio test, limit as n goes to infinity of absolute value of 2 to the n plus 1 over n plus 1 divided by this, which is the same thing as multiplying by the reciprocal. So n over 2 to the n. And when you simplify this, limit as n goes to infinity, absolute value of this is the same thing as 2 to the power of n times 2 over, I'm going to put 2 to the n over here, times n over n plus 1. So this cancels out, and so you get 1 on the bottom. As n goes to infinity, this will approach 1. So 1 times 2 is 2. And that's greater than 1. So we can conclude that the infinite series diverges by ratio test. Also, take a look at it. Remember the n-term test? As n goes to infinity, you know that this will go to infinity because 2 to the n grows faster than n. So by using the n-term test, this also diverges. So we can show that this series diverges by using the n-term test or the ratio test. Let's take a look at this example. You have infinite series from n equals 1 to infinity of 3n plus 1 over n squared. So a of n is 3n plus 1 over n squared. And what is a of n plus 1? That's going to be 3 times the quantity n plus 1 all over quantity n plus 1 squared. So using the ratio test, you have limit as n goes to infinity of absolute value of a of n plus 1, which is 3 times the quantity n plus 1 over quantity n plus 1 squared times the reciprocal of this, which is n squared over 3n plus 1. So you get limit as n goes to infinity of, I'm going to put n squared over here, over quantity n plus 1 squared times, when you distribute this, you get 3n plus 3, and add 1, you get 3n plus 4 over 3n plus 1. Now, when you expand this, you're going to get limit as n goes to infinity of absolute value of n squared over n squared plus 2n plus 1 times 3n plus 4 over 3n plus 1. Now, as n goes to infinity, you know that this one will approach 1 because they have the same degree and the coefficient is 1 over 1. So this whole thing goes to 1. Or you could apply L'Hopital's rule. And as n goes to infinity, this will go to 3 over 3, which is also 1. So 1 times 1 is 1. And since this is 1, this infinite series is inconclusive by the ratio test. We don't know whether this infinite series converges or diverges by ratio test since we got 1 as a result. So we have to use a different test. And if you remember, you should probably try limit comparison test to see whether this infinite series will converge or diverge. Now we have infinite series from n equals 1 to infinity, 1 over n factorial. So a of n is equal to 1 over n factorial, and a of n plus 1 is equal to 1 over quantity n plus 1 factorial. So limit as n goes to infinity of absolute value of a of n plus 1, which is 1 over quantity n plus 1 factorial times the reciprocal of this, which is n factorial over 1. So this is the same thing as limit as n goes to infinity of absolute value of n factorial over, and what is that? That's going to be quantity n plus 1 times n factorial. And the n factorial cancels out, so you get 1 over n plus 1. And as n approaches infinity, this will approach 0. And you know that 0 is less than 1. So we can conclude that this infinite series converges absolutely. Now, before we do this example, recall that limit as n goes to infinity of quantity 1 plus 1 over n to the power of n is equal to e. If you forgot this, you might want to go back and review why this becomes e. So our a of n is n factorial over n to the power of n, and then a of n plus 1 will be quantity n plus 1 factorial over quantity n plus 1 to the power of n plus 1. So when you use the, before we use limit, Let's first simplify. Find out what the absolute value of a of n plus 1 over a of n is. And then we could use the limit as n goes to infinity. So this will be absolute value of this, which is quantity n plus 1 factorial over quantity n plus 1 to the power of n plus 1 times the reciprocal of this, which is n to the power of n over n factorial. So let's simplify this. You end up getting, this is the same thing as quantity n plus 1 times n factorial over, I'm going to put factorial over here, times n to the power of n over, and that becomes quantity n plus 1 to the power of n times quantity n plus 1. I got this from here. Now we could cancel out n plus 1. We could cancel out n factorial, and we get absolute value of n to the power of n over quantity n plus 1 to the power of n. Now simplifying this, you will get absolute value of quantity n over n plus 1 to the power of n. Now notice, I'm going to multiply by 1 over n on the numerator and 1 over n to the denominator, and you end up getting 1 over 1 plus 1 over n, and that whole thing to the power of n. Because I multiply the top and bottom by 1 over n. Now this is the same thing. 1 to the power of n is 1. So you get 1 over quantity 1 plus 1 over n to the power of n. And you could put absolute value. So what happened as limit as n goes to infinity of this? Well, that becomes absolute value of 1 over quantity 1 plus 1 over n to the power of n. And that the numerator stays as 1. But remember, do you remember what we talked about earlier? As n goes to infinity, this thing goes to e. And you know that 1 over e is less than 1. So what can we conclude? So we can conclude that this series, infinite series, converges, since 1 over e is less than 1, by the ratio test.